Today in the presentation, I want to show you who our company Byonoy is, give you a brief introduction into our products that we produce. And since we are quite new to Sila, I can already tease it that, we are mainly here to learn about Sila. We are working on a prototype, and we want to basically know if we're going the right way and learn all from you guys and experts. So let me start. My presentation today is about how Byonoy wants to automate labs with the world's first on-deck microplate reader. And so first about us at Byonoy, who we are. We are a small, or especially young tech company from Hamburg. We have mostly customers in life sciences and in diagnostics. And we do develop, manufacture, and sell plate readers. Right now, mostly for Absorbance, but there will also be others in the future. And our concept at Byonoy is to modernize measurement devices to shape the future of the lab. And this is a common theme, I think, with Sila. We want to all have an influence and change how labs are done for the customer. And first of all, I want to give you a quick tour through our products, and then show you also the world's first on-deck microplate reader. And second, I also want to shortly talk about the challenges that we face or the questions that we have about Sila and how we want to utilize it. So let me show you how we at Byonoy want to re-envision the laboratory. So the industry is basically marked, like talking plate readers, the industry is marked by big machines, big classic plate readers, which you can see here on the left, for example. They are usually they're single and multimode readers, so single mode reader for only absorbance, or multimode reader which also do fluorescence or other things. But all in all, they all are quite big. They occupy a lot of benchtop space in the lab, which is always inconvenient. They are heavy, so it's really unflexible for the end user. And there are also slightly small options, like you can see, for example, this one here on the right. They tend to get a little bit smaller, but they all have the same technology. You basically move the sensor to scan your plate that you have. And this is all, it didn't really have much, they didn't have much achievements or much things that changed there. So the technology is still quite the same. At Byonoy, we try to rethink laboratory and want to rethink measurement instruments. So we want to simplify and streamline the lab workflow for our customers. So the device I will show you shortly is more like in this size category. So it's smaller and enables to have a flexible device for the user. We want to focus on the customer for a great user experience and enable, on the one hand, flexibility, with the small form factor, and also decentralization. And for those of you who don't know Byonoy yet, I would like to show you a new category of plate reader, which is our Absorbance 96. As you can see, the device is just slightly bigger than the plate itself. So our vision with the Absorbance 96 was that we want to give the user complete flexibility with our device. Basically, they do their experiment in the lab, they do their assay, research, and our device is just some hurdle they have to get through. And the easier and the more flexible it is to use the reader to just get to your measurements that you actually care about, also evaluation. We want to give the most flexibility. So our result, basically what we did different than the industry right now, is that we're using a new approach to instrumentation. We have a solid state design in our reader. This is why we can get this small. So we actually have 96 detection units in the reader, not like one or an array that scans, but all is solid state, no moving parts, low maintenance. And the result is the most compact plate reader on the market. And the footprint is almost as small as a microplate, as you can see. So let me show you its features. The small reader size, like I already said, enables the user to have intuitive handling. It's the lightest plate reader on the market too. It's like just a bit less than a kilogram, and this ensures absolute flexibility for the customer. And and one thing like storage, it's really simple to just store it in a drawer anywhere. It doesn't take benchtop space at all if you don't need it. But it also enables sharing and decentralization. So you can share it with your lab partners, or you can actually take it to the experiment where you need it, which is a new thing because with the old readers you couldn't do that. Our Absorbance 96 features an open design. There is basically the plate that you slide in, but there's nothing covering it. Our design works like this. So it allows for quick plate loading. And also, all in all, it's really reduced complexity. All we have is one cable that connects connects to your computer via USB. It is combined power supply and also sends the data, so you don't need an external power supply. All you need is basically the device and a laptop to use the device. And other than the hardware that we changed here and made really as compact as we can, we also wanted to modernize the plate readout itself. So I want to show you our software, which is the Absorbance 96 app. It's basically what we want to achieve with our software is, like I said, we want to make it as easy as possible for the user. So we really aim for a simple, streamlined workflow with our software. Basically, when you want to make a measurement with our device, all you have to do, let's walk through the complete workflow. It's quite simple. You just need to connect the USB cable to the device and your computer. You open the desktop app, and then the desktop app is supposed to have smooth navigation and a logical readout flow. So it's basically a three-part workflow. First, you have your setup. You can see here a part of the setup page. Basically, you put all whatever you have on the wells. You can just enter here quite simply. Can choose if you have blanks or samples or standards. Enter all your data intuitively. Then you have the readout step, which basically does a fast initialization. You don't have any warm-up time. It's quite simple and fast. You insert your plate into the reader, and the result you usually get under 5 seconds. So it's a very quick plate readout too. After the readout, you directly land on the results page, which on the one hand shows you all the measurements that were made, but also gives you different evaluation options. For example, standard curve fitting and things like that. So basically the workflow is quite simple. We try to make it logical and smooth. And the goal with our software is really to have a low barrier of entry for our customers. So the idea is not to have extensive training required. Actually, we want to have no training at all required for the user to use our software. And it should be a modern and straightforward user experience. So enough about our first product that we put on the market about 2 years ago. I also want to show you our decentralized single cuvette reader, which we call the AbsorbanceOne. You can see it here in the middle, the round reader. The idea here is to really have a decentralized UV visible photometer. So in this case, all you really need is actually the device, and even an Android smartphone does work. It can power the device, and you can just simply get your measurements. Our AbsorbanceOne has a minimal footprint. It's really tiny, as you can see. It has automatic measurement. So once you insert the cuvette, you directly get a measurement. You can also have the option to make a reader measurement, but it's very simple. All you have to do basically is you have your cuvette, you put it in, and you have the measurement, then you could take the next, and so on. And it is super flexible. And as I said, we have an Android app, but it still also comes with a desktop app, so you're free to use whatever you like. Exactly, and this is also the most compact single cuvette reader on the market to date. And it's ideal for in-field usage. For example, you have a farmer who wants to make some experiment or test his crops. you can do this right in the field, literally in this case. But also for mobile labs, it's a very interesting application. Tests in front of, I don't know, the university if you have COVID tests or whatever. So there's many scenarios that you can think of where this flexibility really counts. And these are our current products that we have on the market as Byonoy. I also want to give you a sneak peek on the prototype for our next product, which is our world's first on-deck plate reader. Basically, we made the smallest readers on the market for Absorbance, like 96 plate. I showed you Absorbance 96, and also the cuvette reader. So this is really allowing us for decentralization and flexibility for our customers, and really fills the need of many customers in this case. But we also realized that we actually, in modern automation solutions, they also tend to get smaller. You have very limited space, and it's hard to even integrate classical plate readers. But since we have such a small footprint, the next logical step for us was to basically do what we're good in and create a small reader which is easily integratable into existing automation solutions. So this is the Absorbance Automate, that how we call it. Basically, you can see this reader consists of two parts. You have the bottom and the top part of the device. And basically, I think here you can see that better. I will go through the workflow real quick. It's designed for robot automation. So all you have to do is you have a small pick-and-place robot. You basically pick the top away. Then you have the empty, the unoccupied device space. You just pick and place in your plate, and you set the top part on it and can make a quick measurement. And since we have such a small footprint, we actually have an adapter that is slightly smaller, but is exactly the size, the one that you can see here, of the microplate itself. So if you have an on-deck solution where you basically can store multiple microplates and do different things on it, you can just set our device in the deck. So that's why we call it on-deck plate reader. And this is not possible with other plate readers, since all of them are much bigger and they just wouldn't fit on such a form format. But ours you can basically just put in and plug and play. And all you have to do is program the robot to actually pick and place also our top and not just the plate. And then you can make automated measurements. What you did is basically take the Absorbance 96 technology, put it in a different plate, also had some improvements. But that's how we arrived at our plate reader for automation. Now, since we talk about automation, we want to automate labs. And we're here because it's a CELA conference, so or a hackathon. And we were thinking about how to integrate our devices in general, but especially for automation, it's a really interesting point for us, right? So we want to use CELA 2 for automation. And we're, like I said, pretty new to CELA, and we have our first prototype that we're working with. We also have it with us, which is the automation, Absorbance Automate that I just shown you. And on the current state, the first prototype, basically we have our desktop app that can also run a headless mode that runs a CELA server that you can connect to. And we can do the lab automation over the CELA server. Basically, you tell the CELA server to make a plate readout, and our desktop app sends it then to the device and communicates with the device. So we can load protocols that are predefined or that the user before defines, execute the measurements, and then in the end export the results. And what we want to do for this prototype is also use CELA 2 4-limbs integration. Right now we have quite basic export features, but that really works in an automation environment. We need to somehow use CELA for exporting our data. So we want to use Animal for this. And this is still not done. That's why it's pending. But we want to learn more today and tomorrow here, so we can go on with our prototype and basically have a full-blown automation solution that talks Sila first over our desktop app. And then after this, also want to talk about a possible future here. We have a plate reader that communicates directly with Sila 2. So that's one idea. Should our device directly talk Sila 2, or is it enough if we have desktop app? But let's say we need it, and I think there's potential on the market for that. What does the measurement device really need to deliver to the customer? So is it enough if we just have raw measurements that we send out? Because right now all our device does is talk to our desktop app, which does all the evaluation, but we just receive a command to execute, to make a measurement with decent wavelength, and the device reports the measurements that we have. So would this be enough for an automation use case for a device that talks Sila 2 by itself without any other software? Or would we also have to do some evaluation that currently we do in our software? Evaluations like concentration, standard curve fitting, and things like that. So that's an interesting question for us. And also if there's other metadata that we have to basically send with the Sila 2 server to the user. So we can have a maximum benefit for the customer, basically all the data that he needs or could use. And apart from Sila, also regarding animal, we want to know how we should structure our animal file so it's really usable for the customer, that it also includes all the data that we need to send, and also what data should be in there again. So do we need like plot curves or something? If the device itself talks Sila 2, so then we also have to export it with animal. And in the first step that I've shown you before, we again want to use animal also with our software to export all the evaluation that we have in the software. So we would like to learn about this here, and in this hackathon we want to basically understand how Sila 2 works better. Also, we want to understand how Sila works better, but also are really interested about the best practices from the industry, and how other devices implement Sila and animal and communicate with each other. So I also want to give you a quick outlook on the future of our products. The Absorbance Automate is right now in the development pipeline. We want to bring it out of Sila. But we also have some other things coming up. For example, our Luminescence 96 reader, which is the first other reader type in our company. It will be a state-of-the-art luminescence reader. Will have a similar small form factor like our other readers, which is again pretty new on the market, and should come with our known streamlined Byonoy user experience. And we are a very young company still. We are growing and want to make new products, so this is really just the beginning for us. And with that, my presentation will come to an end. I'm really happy to talk to all of you in the hackathon. And yeah, thank you for your attention and for your time. And I'm looking also, I think I can talk for my colleague Carl. We are really looking to hack with you the next 2 days and to talk. Thank you very much.